What if the ugly rock you almost kicked aside was actually a clue to something valuable? Most people search for gemstones by looking for color, sparkle, or obvious crystals. Experienced rockhounds often start somewhere else. They look at the rock itself. A dull, volcanic stone. A chunk of gravel cemented together. A rock containing unusually large crystals. A dark, volcanic body that looks like ordinary dirt. Or a rounded stone whose exterior reveals almost nothing about what's inside. Most are completely ordinary. But under the right geological conditions, rocks like these can be associated with opals, diamonds, rare gem minerals, and spectacular specimens. Today, we're counting down 5 rocks that can fool the untrained eye. You'll learn what to look for, how these rocks form, how to test suspicious specimens, and why some of the minerals associated with them can be extraordinarily valuable. And number 2 is connected to one of the greatest diamond discoveries in history. But number 1 may be the ultimate example of hidden treasure. Because with this rock, the outside can tell you almost nothing about the inside. 5. Conglomerate. Conglomerate forms when rounded fragments of older rocks are transported, deposited, buried, and eventually cemented together. In many places, it looks like hardened river gravel, but every pebble inside it came from somewhere. A river may have carried material away from an older outcrop, worn the edges smooth, and deposited those fragments downstream. So, conglomerate can preserve pieces of a geological landscape that may no longer be exposed nearby. Look at the individual fragments. One may be quartz, another could be jasper or chalcedony. Occasionally, you'll find a fragment with unusual color, transparency, texture, or crystal structure. That's when you should ask, where did this come from? A 10 times loop can help you examine inclusions, crystal faces, fractures, and luster. And if unusual fragments become more common as you move upstream, you've gained something more useful than a pretty pebble. You've gained a directional clue. That doesn't guarantee a valuable deposit is nearby. Rivers can transport material considerable distances. But conglomerate teaches our first lesson. Sometimes the rock isn't the treasure. It's the evidence pointing toward the source. 4. Basalt. Basalt is one of Earth's most common volcanic rocks. Finding it isn't unusual. Finding something inside it can be. When basaltic lava erupts, gases can form bubbles in the molten rock. As the lava cools, those bubbles become cavities, called vesicles. Later, groundwater can move through the rock, carrying dissolved silica and other elements. Minerals may then precipitate inside those old cavities. Chalcedony can form, quartz can grow, and under suitable conditions, opal can develop. That's why a basalt specimen with mineral-filled cavities deserves a closer look. But don't assume every translucent material is valuable opal. Common opal can be attractive without showing the colorful flashes of precious opal. Precious opal can display spectacular play of color, and quality varies enormously with color, pattern, stability, size, and clarity. Fine Australian black opal jewelry has reached 5-figure estimates at major auctions, showing just how valuable exceptional material can become. But that doesn't mean rough opal-bearing rock is automatically worth thousands. It isn't. And not all famous opal deposits occur in basalt. Lightning Ridge, for example, is famous for black opal associated mainly with weathered Cretaceous sedimentary rocks. So don't memorize, basalt equals opal. Remember instead, cavities can become traps for later mineral-forming fluids. 3. Pegmatite. Pegmatite can look like extremely coarse-grained granite. Then you notice the crystals. They're unusually large, sometimes enormous. Pegmatites form during the late stages of crystallization of certain magmas, when the remaining melt becomes enriched in water and elements that didn't easily fit into earlier minerals. Under the right conditions, Those ingredients allow crystals to grow dramatically. And some pegmatites contain important gem minerals: tourmaline, beryl, topaz, spodumene. Minas Gerais in Brazil is famous for spectacular pegmatite minerals. But here's the important distinction. Large doesn't automatically mean valuable. A huge crystal can be fractured or poorly colored. A much smaller crystal can be worth far more if it has exceptional color, transparency, rarity, and quality. Paraíba-type tourmaline is a perfect example. Its intense blue-to-green color and scarcity have made exceptional stones extremely valuable. In 2025, Christie's sold a Tiffany & Company necklace containing a 13.54 carat Paraíba-type tourmaline for $4.223 million. That's exceptional finished jewelry, not raw pegmatite. The value comes from the extraordinary mineral. So when you find unusually large crystals, don't simply ask, how big are they? Ask, what are they? That question can completely change the significance of the rock in your hand. 2. Kimberlite. Now we reach a rock with a very different reputation: kimberlite. It rarely looks like a diamond-bearing rock. Weathered kimberlite can be dark, earthy, and surprisingly ordinary. Yet certain kimberlite pipes can contain diamonds. Natural diamonds form under extreme pressure and temperature in Earth's mantle. But once a diamond forms deep underground, it needs a rapid geological elevator to reach the surface. Kimberlitic magma can rise through the crust, carrying fragments and minerals from deep within Earth. Some diamonds can survive that journey. That's why kimberlite matters. Not because the rock itself is beautiful, but because it can transport material from the deep mantle toward the surface. Geologists can also study indicator minerals associated with some diamond-bearing systems, including particular garnets, chromite, and ilmenite. But finding kimberlite doesn't mean you found a diamond mine. Most kimberlite bodies aren't economic deposits. Real exploration combines mapping, geochemistry, geophysics, sampling, and often drilling. And one famous discovery shows what the geological payoff can look like: the Cullinan Diamond. On January 25, 1905, a remarkable diamond crystal was discovered at the Premier Mine near Pretoria, South Africa. It weighed approximately 3,106 carats. The stone became known as the Cullinan Diamond. It was eventually cut into 9 major-named stones and numerous smaller diamonds. The largest became Cullinan I, the Great Star of Africa, weighing 530.2 carats. The important point is that it didn't emerge from the ground as a finished jewel. It began as rough geological material. Its significance became clear only after its size, quality, identity, and geological setting were understood. And that's why kimberlite matters. The rock itself isn't necessarily the treasure. It can be the map to the treasure. 1. Geode. And now we reach the rock that best represents the mystery behind this entire video: the geode. From the outside, a geode can look completely ordinary. Rounded, weathered, unremarkable. You may have almost no idea what's happening inside. And that's precisely what makes it fascinating. A geode contains a cavity that can become lined with minerals. In volcanic environments, that cavity may begin as a gas bubble. Later, mineral-rich fluids enter. Silica precipitates. Chalcedony can line the walls. Quartz crystals grow inward. And in suitable environments, other minerals, including opal, can occur. Over geological time, an empty cavity becomes a miniature mineral landscape. Brazil and Uruguay are famous for spectacular amethyst geodes, but value varies enormously. A common commercial geode can be inexpensive. A large, intact specimen with exceptional crystals, color, locality, and aesthetics can become highly desirable to collectors. And the same principle applies to gemstones inside. Species matters. Quality matters. Size matters. Rarity matters. So don't assume every geode contains a fortune. Sometimes you open one and find ordinary quartz. Sometimes there's almost nothing inside. And occasionally, you get something spectacular. That's why an interesting geode deserves patience. Study natural fractures, examine its shape, consider its weight. And if it appears unusually promising, professional cutting can be much safer than smashing it with a hammer. Because the geode gives us the perfect lesson. The most important part of a rock may be the part you cannot see. So what separates someone who simply collects rocks from someone who thinks like a prospector? It's what happens after the first discovery. You find an unusual stone. Instead of immediately asking how much it's worth, you ask where it came from. You examine the surrounding rocks. You compare specimens. You study the landscape. You follow the evidence. And every new observation either strengthens your theory or destroys it. The first clue creates curiosity. Several independent clues can create confidence. That's when rockhounding becomes geological detective work. The best discoveries don't begin with, "How much is this rock worth?" They begin with, "What is this rock trying to tell me?" The next time you walk across a rocky landscape, don't only search for something beautiful. Search for something that makes you curious. A pebble that doesn't seem to belong. A cavity filled with unfamiliar material. A rock containing unexpectedly large crystals. A dark, volcanic body that looks strangely out of place. Or a rounded stone whose exterior reveals nothing about what's inside. Most of the time it will be ordinary, and that's perfectly normal. Prospecting isn't about finding treasure every time. It's about learning to recognize the evidence that tells you when a second look is justified. Because sometimes that second look leads to an opal. Sometimes it leads to a rare crystal. Sometimes it reveals a geological system extending deep beneath the ground. And sometimes, against all expectations, an ordinary-looking rock becomes the beginning of a remarkable discovery. The earth doesn't put price tags on its treasures. It leaves clues. And once you learn how to read those clues, you'll never look at an ordinary rock quite the same way again. Look, wonder, learn, test, discover, value. This is P. Rowe Gems.